starting with rational expressions. So our agenda for today, we've got a new game to play at the beginning of class, I know. And then we're going to be going into radical expressions. What is a radical expression? Factoring polynomials and simplifying radical expressions. So this is our new game. It's called Which One Doesn't Belong? There is no wrong answer to this. So I'll give you an example, like, I'm going to say the apple doesn't belong because it's the only one here that doesn't have a leaf. That's the only one that has a leaf on it. So that's why the apple doesn't belong. Any other ideas of what wouldn't belong? How about the orange? Why wouldn't the orange belong, do we think?
It's the only citrus.
Yeah, it's the only citrus fruit here. Okay, I'm gonna start calling on volunteers. Grapes, why wouldn't the grapes belong? They're purple. So basically, this is kind of a way that we can get into our lesson and kind of get back from the normal world and come into math world. So we'll be doing one of these each day. They're just kind of fun, nothing major. So we're going to start here with our first paper. It's going to be here, simplifying a rational expression.
Oh, please have some. Thank you.
So basically, a rational expression, this first thing up here, it's a ratio whose numerator and denominator are polynomials, and the denominator is non-zero. So go ahead and fill in those blanks on the top one here. And I apologize, the Spanish translation will be ready on Monday. Unfortunately, I did not have a chance to get that ready for today, but it will be ready for Monday. So here's an example of a radical expression. X squared plus 5 divided by x plus 2. So when you're looking at this x squared plus 5 over x plus 2, does that remind you guys of anything? We're going to be treating our rational expressions a lot like fractions. You see we have a numerator and denominator, so we're going to be treating these like fractions. So we're going to be doing a lot of the same things we did with fractions, such as least common denominator, doing things, making sure that our denominators are matching. Those types of things are going to be done here. So a rational expression is basically just a fraction with polynomials. So here's some examples, like 1 over 2 minus x squared. And this guy, he's just 2x squared plus 3. We can write him as a rational expression just by putting a 1 underneath. So these are all examples of different rational expressions. So we're going to do this, we need to factor polynomials. And I know we've all slept a little bit since Christmas, but this was the stuff we were going through in November and December. We were doing all of our factoring in November and December. So since I know that you've all demonstrated to me you can factor, we're going to go ahead and we're going to take a little shortcut and do that on here. And the reason we're doing that on here is because we're going to be factoring a lot. And since we're factoring a lot, I want you guys to have the calculator to be able to use to help you out. So I want everybody to go in and turn on your calculator. And it should come up with a home screen that looks something like that. So the first thing we're going to do is click on the scratch pad button. That's right over here. And it should come up with a nice little scratch pad. Then what we're gonna do is click on the menu button, and we'll be bringing up our menu here, and we're gonna select algebra first, so we can type in 3. And then we're gonna type in the number 2 for factor. So now you will see something that looks like this. So, go back. So yes, we'll go in here, do the menu, press 3, then press 2, and then press enter, and that will give you the screen to start factoring. And that screen is gonna look just like this. So the first thing I'm gonna have us factor, go back here. So what I'd like everybody to factor is x squared minus 5x minus 6. And I'm gonna walk around and see what you guys get for an answer. X squared minus 5x minus 6. And then just hit the enter button, it should give you and then just hit enter, yeah. And then go ahead and put in x squared minus 5x minus 6. Perfect. So what you guys got? Okay, go ahead and hit enter. Wonderful. Okay, go ahead, I want you to factor x squared minus 5x minus 6. And then just hit enter. Wonderful. Okay, so go ahead and go back and then menu. You're gonna hit 3 and 2. And then go ahead and put in x squared minus 5x minus 6. And enter. Perfect. Looks good, yes. Wonderful, yep. Yep. All right, so it looks like everybody got the x minus 6 and the x plus 1. So these two here are our factors. So once we have this, we can go ahead and put this into our equations that we will be working on today. And we'll go through some examples of those in just a moment. Okay. Got a little thing here just to give us a step-by-step of how do we simplify rational expressions. First thing we want to do is factor everything. So unless you have something, let's say a 2x in your denominator, you want to make sure you're making sure you're factoring everything. So for our second step, we're going to cancel factors, not terms. So here, we'll go through that again. Now, let's say we have two factors that are close to canceling, we're going to factor out a -1. An example of that would be something like so something like this, where they're close. You have an x minus 3 over 3 minus x. Close, but not quite. That's where we're going to use this factoring out a -1. And you'll see as we go through today, we'll show you how we do that. And then that way we can get them to match so we can cancel. And then we want to make sure that we check to make sure the final answer is fully reduced. Something like this, 4 over 2 would not be fully reduced. So that's kind of what we're looking for, is improper rational expressions. We'll go through some examples of those also. What's the difference between a factor and a term? Let's look at the bottom here. So I've got my x squared plus 2x plus 1, x squared plus 3. These have not been factored yet, neither of them have. So since they haven't been factored, we don't have a x plus, or x minus 2x plus 1 type of thing going on, we can't just cancel the terms. Well, it's a term where it looks like this, where it's just the x squared like this, and we haven't factored it out yet. That's called a term. That is not what we want to do, because when we do that, we get an incorrect answer, and we don't want to kill any kittens, please, because kittens are cute. So what we're going to do is just, it's kind of a step-by-step of simplify. So as we go on today, hopefully you will be able to see where we are doing these types of things. And this can go into your folder when you're done. If you haven't picked up a folder, go ahead and pick up a folder up front here. And I have, as I said, 4 people who are missing, so we will go ahead and we will get those folders for you for next week. Okay, so a monomial, going back to review, it's just a polynomial with one term. So instead of like x squared plus 2x or x cubed minus 3x, it's just going to be one term. So like in our example we're going to be doing is going to be like 16y squared z squared. So that would be a one-term polynomial or a monomial. So when we simplify those, we're using the rule of exponents. And I did print this out and put it on everybody's table because we're going to be using this probably through the end of the year. Just a quick reminder of the rules of exponents. So like what we did with polynomial multiplication and division. When we're multiplying our exponents, we add the exponents together while keeping the base the same. So that's like my x squared times x cubed is going to be 2 plus 3, or x to the 5th. When we're dividing, we subtract rather than adding. So here we have x to the 5th divided by x cubed. So that would be the same as x to the 5 minus 3, or x squared. So these are just reminder, we're going to be going through these throughout the year, so I'm just going to keep this on your tables just to kind of remind you in case you want to remember those types of things. So now what I'd like everyone to do is we're going to pick up our paper packet here, and we're going to work on our first example, the one that says monomial over monomial. That says use the rule of exponents. So that's where we're getting our adding the exponents or subtracting the exponents. So let's go ahead. I have 16x y squared z squared over 4 times x to the 5th y squared. Yay, it's a mess. Let's go ahead and factor this. So for 16, I know that's going to be 4 times 4. And we got an x here, so I'm going to put in x. Y squared, so y squared is y times y. Z squared is z times z. And we've got 4. X to the 5th, so we got 5 x's down here. And then y squared, so we'll have 2 y's in there. So this has everything factored out. These are 2 monomials, and we've totally factored them out. After we've factored everything out, we can start canceling things. So I'm going to go ahead, and I'm going to cancel out a 4 and a 4. Do I have any x's here? Yes, I have one. So I'm going to cancel this x with this x. And take this y out with this y, and move this y with this y. So what we are left with is 4. We have 2 z's, so that's z squared, divided by x the first, x the second, x to the 4th. So that's our first example. That's one of our easier ones. If you don't want to actually put this all out so far that it looks crazy, we can also just do this here. We can go at a 1 here and a 4 here. So we can do canceling on the problem. So we have an x and an x to the 5th. That's going to be x 5 minus 1, x to the 4th. So this we can change to a 4. And then we get rid of that. Y squared and y squared, we can get rid of that. And then we'll have z squared. Come on, y squared, come here. So that gives us 4 times z squared over x to the 4th. So you can do it either way. You can either spell everything out if you'd like, or you can just do your subtraction up in the problem. So we got all that one. Now the next thing we're going to do is what we call a here we are. So in case you didn't get that. Polynomial, we're doing a polynomial divided by a monomial. So for this, what we're going to do is we're just going to kind of tear our equation apart and divide each term of the polynomial by the monomial. So for B here, our second example, we've got 9x squared minus 21x plus 3. It's all divided by 3x. So what we're going to do here, we have 9x squared divided by 3x minus 21x divided by 3x plus 3 divided by 3x. So that's what we mean by divide each term of the polynomial by the monomial, is we just kind of split it into 3 sections here. So we can do our division. What is 9x squared divided by 3x? You know that 9 and 3 cancel, that's going to be 1, that's going to be 3. So we got, basically we're going to have 3x, because we have this x here, and we'll have x to the 1. So we have 3x minus, what is 21 divided by 3? Yep, and x divided by x is 1. So that's just going to be 7 plus, we got 3 over 3x here, so we can, that's going to equal 1. So let's put 1 and 1 here. That's going to be 1 over x. So we can reduce that down to 3x minus 7 plus 1 over x. And that is how that one simplifies down. Yes? Yeah, they did. I'll make sure everyone's getting these down. So if you don't want to do the 1 over x, you can also do a remainder of 3 from our polynomial division. But right now we're just going to keep it simple and call it the 1 over x. Okay, great. I'm going to go on to the next example. Our next example is going to be a polynomial divided by a polynomial in factored form. This is our goal. This is kind of what we want to get to before we start simplifying. This is polynomial divided by a polynomial in factored form. So here we are. So what this would be x squared plus 7x plus 12 divided by x squared plus 3x minus 4. So this would be our polynomial in the standard form, which we'll hit next. Once we factor these, we have this loveliness. And this is what we want to get to because this makes it easier for us to cancel. So if we're looking at the x plus 4 times x plus 3 divided by x plus 4 times x minus 1, what can we get rid of out of this? What do we have matching on the top and the bottom? X minus 4. So we can cross both of those out. Now we have our answer. X plus 3 over x minus 1. That's why we want to factor everything and get it down to this form, because once we have it down to this form, it's much easier for us to cancel factors. We can't just come up here and cancel these. So that's factoring, that was a term from our kitten here. It says cancel factors, not terms. These are our factors, that's terms. So we don't want to cancel just the x squared there. We want to just cancel out the factors that match to give us our answer. And that's the difference between a factor and a term. Okay. Looks like everybody's got that one. Great. Go ahead and erase. So now this is one, number D on our sheet here. This is what we're more likely to see as our problem. It's in standard form. So first we're going to factor our numerator and denominator as needed. And then we can simplify once we've factored. So let's use this example here. I have x squared plus 15x plus 54 divided by 12x minus 72. Let's go to our handy dandy calculator and get some factors for that. Oh, that's right, I unplugged you, didn't I? You guys are plugged in again. Okay, so let me get rid of that. So now we have a clean screen again. So our top one here was x squared minus 15x plus 54. So menu 3 for algebra, 2 for factor. So it'd be x squared minus 15x, plus 54. And what answer do you guys come up with for that? What factors do you guys get when you plug it into the calculator? Should have x minus 9 times x minus 6. So that's that is the factors for our numerators. Let's go ahead and hit the denominator. So for the denominator, we're going to do the same thing. We're going to go 3, 2. And we are doing 12x minus 72. And then we'll hit enter. We have 12 times x minus 6. So I'm going to go ahead and I'm just going to put these values back into my equation. So here we are. So then what we'll have is x minus 9 times x minus 6. It's going to be divided by 12 times x minus 6. So we are fully factored out, top and bottom. What, if we look at this whole mess, what would you like to get rid of to make this a little bit easier?
X minus 6.
X minus 6. Let's go ahead and get rid of both of these x minus 6's. That's going to give us x minus 9 divided by 12. Easy peasy, Bob's your uncle. So once we have it factored, the factoring is going to be the tough part. Once you have it factored, then it's just pretty much we match, get rid of things, and then print out our answer. And then looks like we've all got this. We're gonna go over the next page here. I'm just gonna move on. So we have x minus 9 over 12. So this, if you're looking at it, you might be going, huh? What this means, come over to the other side here. Let's say we have x minus 3 divided by 3 minus x. This is when we use our -1. Because we know if we multiply this bottom times -1, we're gonna get x minus 3. Then we can cancel those guys out. So when you see something like this, where it's backwards, looks backwards-ish, that's wonderful. You can go ahead and just use the -1 in there. So let's say we do 3 minus x times -1. So what is -1 times -x? That's gonna be positive x, yes. Now how about -1 times 3? -3. So see, now we can cancel these two terms out. So that is something that we're gonna be working on also if you see something kind of funky in your denominator. So let's go ahead and I'll work on the problem here. Okay, so our problem here is x squared plus 3x minus 10 over 2 minus x. This is our beep, beep, beep. Then we're gonna have to do a -1 multiplication when you see something like that in the denominator. So what is the first thing we want to do when we're simplifying a rational expression?
Factor.
You want to factor, yes. So what we're going to do is I'm going to move screens again, and we're going to go ahead. We're going to clear off that screen so it's less confusing. So now we're going to factor. So our first factor here, and you 3, 2, get our factor pen. It's going to be x squared plus 3x minus 10. So when I enter that, I have x minus 2 times x plus 5. So what I'm going to do is I'm going to go back to my problem and substitute in x minus 2 times x plus 5. So let's go back to our problem. Boom, boom. So we've got here, on top I've got x minus 2 over x plus 5, or times x plus 5. It's all going to be divided by 2 minus x. So when we look at this, going, if I do the -1 thing, I can get rid of that. So let's go ahead, and what I'm going to do is I'm going to multiply the whole kit and caboodle times -1. Because what is -1 divided by -1? It's going to be positive 1, so it's just like multiplying it by itself. So that's why we're going to multiply times -1, -1. So I'm going to come over here. So here I've got, so 2 minus x times -1. What is -1 times -x? It's going to be x negative, so it's going to be -2 plus x, or x minus 2. So let's go ahead, and I'm going to go over to my equation here. So I've got, I have to put that one down a little bit. 2 minus x. So what we have here is x minus 2 times x plus 5 times -1. And it's all divided by x minus 2. Now we have something we can cancel out here. So I'm going to get rid of my x minus 2's. The other side. So what that's going to give us is x plus 5 times -1. So we can do x plus 5 times -1. So what is -1 times 5?
-5.
-5. And what is -1 times x? -x. So that's going to equal -x minus 5. So those are the different types of things that we're gonna be doing when we're working on solving and simplifying these next problems. So I've got about 13 minutes till 3. So I'm gonna go ahead, we're gonna take a brain break and come back at 3. So everybody can run off, go to the bathroom, get your drinks,